Hello, everyone, and welcome to a quick video here on Chapter 8. So let me share my screen. And in particular, this video is on the topic of Solver, which is the last of our tools for the what if analysis. And so I'm going to navigate to the right spot. Let's see here. There's a picture of the boiler that got you out of class today. They're doing demolition and asbestos abatement. Not the funnest way to spend a big chunk of money, but we will have heat here for the winter, so that's important. And so for this particular example or this demo, there is a file that is in Moodle with the week 8 demo files. This one is called the Grills demo. And this example is going to use Solver, which I'll talk about in a second, but it is a income statement like the river rafting example that also is a bit more complicated. And so, as we've been talking about in chapter 8, we build a spreadsheet that has inputs and processing and outputs. We have this idea of uh, a model that, an income statement is a model of the future, and we could do various what ifs, changing the inputs to say, well, what if we had a long season? What if we had a short season? This example is a little more complicated, but not too much. And in the solver realm, we are going to be given spreadsheets to apply solver to. We're never going to have to build one of these from scratch. And so on the left-hand side is an income statement, very much like the river rafting in that I put in how many of each grill type that I sell. So now we're not just selling a river rafting ride, we're selling a barbecue grill, but a grill is not a grill is not a grill because there's a standard model, there's a deluxe model, there's a dual model, etc. And it will figure out for us what our variable expenses are based on the mix of products we make. It will figure out how much we would sell them for because they also have different selling prices. And then down at the bottom, it takes our revenue, our variable expenses. It has 30,000 of fixed expenses applied to this product, and then it gives us our net income. And so if I put in numbers, if I say, well, let's make 100 standard grills, 100, oops, I'm gonna go over here, 100 dual, 100 deluxe, and 100 extended, it would figure out here are my variable expenses, here's my revenue, here's my net income. It is set up to do that. And obviously, at 100 of each kind, I'm still losing money. But what is more sophisticated about this example is it's not just saying, what if we made this many grills and sold them? But also, we have some limitations. In the real world, we have things that limit how much we can make. And so, in this particular case, we have a list of parts that go into these grills. This is how much we have in our warehouse that's available. And again, that's a limitation. If I only have 1,400 main burners, I can't make more than 1,400 grills that use main burners, except that some grills might take more than one part. And so we have to take that into account. And so that's what the rest of this spreadsheet does over on the right, is that it shows me how many are available. When I put numbers into B4 through E4, it shows me how many are ordered. So it does that math for me. There are equations here that I don't want to modify. It then figures out how many remaining parts there are, which is simply a subtraction. Take the number available minus the number ordered. That's what's left. It has the cost here of each part. So when it does the costing of what our variable expenses are, that's where this information comes from. And then columns L, M, N, and O are the recipes for the various kinds of grills. And so when they build them, a standard grill has one control dial. A deluxe has two, a dual has two, and if you buy the Cadillac of grills, the extended grill, it has three. And so, depending on what I build, will use different numbers of parts and cost different things. And obviously, over on the revenue side, because the grills have different configurations, they also sell for quite different prices. A standard grill only sells for 155. I can get twice that much money for an extended grill. And so, what we would normally do in class for this activity would be to say, well, we've got this situation, we've got four inputs. I've got a limited number of parts that are shown to me in columns H, I, and J. And my goal in using Solver is what's called optimization. And optimization means we want to not just find, the break-even point, where does net income equals zero or some particular value. We want to know what's the maximum, the optimal mix of products we could make in order to maximize net income. Or we can also minimize, we probably don't want to minimize net income, but we might want to minimize costs. There are applications of this for scheduling of deliveries. Again, if I'm UPS and I have a bunch of packages, I want to minimize the amount of distance that I have to travel to, complete all those deliveries. And that's an example of a minimization problem. And so in this case, what I would oftentimes have you do is try putting numbers into B4, C4, D4, and E4, the four input cells, and see how far you could get net income to get positive. I got there almost there with 100, 100, 100. There's no rule that they have to be all exactly 100 or exactly the same. I could build more of one kind and less of another. But all the time that I'm trying to find the maximum value, I need to keep in mind that my remaining parts can't go negative. Because if I have negative parts, that means I can't build them. And so usually I'll let people have 5 minutes or so to do trial and error. They, pick numbers out of the air, plug them in. If they're too low or you still have parts left, you increase it, etc. You go around. Eventually, people get a positive number. And then the question is, well, how big could I make net income? What's the optimal combination? And again, after 5 more minutes, we get a number. Sometimes it's 20 something thousand, 30 something thousand, 40 something thousand. The number keeps going up and up. But at some point, progress slows down and nobody in the class is able to find a better combination. And the question becomes, after, 10 minutes, is that enough proof or evidence that we've found the optimal value? Or should I do this for an hour? Or should I have you do it for a week? How long would we have to be at it trying different values in order to prove or have a pretty strong understanding? And that's a tricky question, and we don't want to spend a day, a week on this. We want to know what's the optimal answer in a matter of a few seconds. And so there is this tool that we're going to use called Solver, and Solver is going to allow me to find the optimal value. And Solver is a tool that lives on the data ribbon. Now, for 99% of you watching this video, when you look at the data ribbon, you might see, you will see what if analysis, because that's chapter 8. You might see forecasting, you might see outline. You probably don't see these two items. We don't need data analysis for this chapter or this course. You will use it some in uh, MIS 379, the quantitative methods class. But if I'm going to use Solver, I need to turn it on before I actually can use it. And so once you turn Solver on, it will stay turned on. And Solver is what's known as an add-in. And so on a PC, I can turn on this add-in by going to File, and down at the bottom, there is an item called Options. And when you push that, it will bring up a window in the center of your screen. If you're on a Mac, I believe you have to go to Tools and then Options, or Tools and Add-ins. It's one of those two. If you have trouble, just search add-ins on your Mac Excel file or Excel application. I'm going to go to add-ins on my PC, and both the Mac and the PC, when you get to the point where it says add-ins, and my computer is thinking here, it should give me a option down at the bottom that says Manage Excel Add-ins and the word Go. When I click OK, this is the window that pops up that is exactly the same in both a Mac and a PC. And I want to check the checkbox to turn on Solver add-in. If you want to add the analysis tool pack, there's no harm. It takes up a little bit of memory, but it's free. And again, you'll probably use it in MIS 379. There's a Euro currency tool. I turn that off only because I don't deal with Euro currency all that often. And this VBA option is again something beyond what we're going to do. So I'm going to click OK. And when I do that, in my case, the solver stays turned on. And this is going to now show up on your data ribbon. And like I said, once you turn it on a computer, it will generally stay turned on. In the computer labs, they do occasionally refresh the software. So if they reset the software, you may need to go back in and do it. But if this is your own computer, once you do it, it should stay turned on unless you were to ever go back and uncheck that checkbox. And so when I click Solver, it is going to give me a window that pops up that has a number of pieces in it. It's a little bit bigger than GoalSeek. It's actually a lot bigger than GoalSeek. And GoalSeek is Solver's little brother. We use GoalSeek to say, how much of a car loan could I take out if I wanted payments of $300 a month? And we set the output to a number. We said, change this one input, and it would work its way through to tell me the answer. In this case, I want to say, what is the objective? In this case, our objective, the thing that we want to maximize is net income. It has to be a calculated cell, an output. And in this spreadsheet, that is B19. And I also have to tell Excel what are the changing cells? What are the things that I'm going to let Excel want to vary? And that is B4 through E4, the four cells in yellow under standard, dual, deluxe, and extended. These would be the same four cells you would have been playing with if you were trying to manually do this. And if I identify the output and I identify the four inputs or changing cells, when I click solve, Excel will try to follow my command. We're trying to maximize net income given those four inputs. And when I do this, I'm going to actually get a bit of an error message. This is an exclamation mark. It doesn't say it found a solution. I'm going to click OK just to see what it did. And, on the surface, it might look like I'm going to make a lot of money. You look at, what is this, 1 billion, 119 million, not 294, well, it's even more than that, trillion, 1 trillion, 1.1 trillion. And so, obviously, it would be nice to be a trillionaire, but I can't do it because we would have lots and lots of millions, if not billions, of parts that are not here to do that construction. And so when I run Solver in that window, I have to specify the output, the input, but I also have to give it the constraints. And so on the right-hand side, I can say I want to add a constraint, and my first constraint is going to be the fact that the number of remaining parts, cell J3, has to be greater than or equal to 0. And J4 has to be greater than or equal to 0, J5, J6, J7. You might say, well, that gets repetitive if I had to enter those one at a time. So instead of putting J3, I'm actually going to highlight J3 through J14. I'm going to click OK. And it will now add those constraints to the constraint window, meaning it won't let me run out of parts. And if I click solve, it will give me and tell me it found a solution. So that's a good sign. I'm going to keep my solution for a second. And now if I look at, well, what does it suggest as the solution? I'm going to be a little bit surprised to see, well, dual grills has a negative number. And again, we didn't tell Excel that a negative number wasn't a possibility, and it has a logical reason for doing that. If I take if you look at this, extended grills have a higher price. They sell for $315. They only cost, I shouldn't say only, but they cost 203. There's $112 of profit here versus a dual grill. I only make $70 of profit. And a standard grill only has $49 or 48.50 of profit. And so in that way, if I'm trying to make as most money as possible, I want to use the extended grills as much as I can. And the negative number here actually is akin mathematically to disassembling dual grills and putting parts into inventory, which can then be reassigned to the more profitable extended grills. Obviously, we're ever told that we had grills we could disassemble. So in Solver, one of the things we oftentimes have to add as a constraint, and again, in a SAM project, they would, be specific to you, is that these four cells, B4 through E4, have to be greater than or equal to zero, sometimes known as the non-negativity constraint. And so, here we're talking about grills. In other instances, you're talking about, days out of the week, a number of days out of the week, or a number of hours in a day. And again, you can't have a negative number of days in the work week. You can't have a negative number of hours. And so we're saying, these things have to be greater than or equal to zero. And if I now tell Excel to solve, it's going to apply that solution, and net income is going to go from 53,000 down to just under 46. And again, it will give me values. I can look at the remaining inventory, and there's a few things that are at zero, but nothing is negative, so it's doing its job. The only wonky thing here is it's making half a grill. And it's assuming I can sell that half a grill for half price and I can build it for half price. Again, who's going to buy a half a grill and what does a half a grill really mean? And so there's a reality here that I need to tell Solver, because Solver lives in the mathematical world, that B4 through E4 have to be whole numbers. And in math, that is, calling them integers. And so I set the integer or int constraint, click OK, and then when I run or click solve for solver, it will come up. It tells me it found a solution with the new constraints. My net income did drop slightly. And this is now, for this set of constraints, the optimal set of grills to build, given that I have these limited number of parts. And so that is the solution. And obviously, if I then wanted to do more what if, I could say, well, what if we add more parts? And then how much would that cost? How much would net income go? We could do a cost benefit analysis. And so Solver gives us that ability to find the optimal solution. The other thing I'll just point out, going back into Solver and then just rerunning it, the answer won't change because we're already at the solution. But when you run a Solver model, at the end, it does give you the option for an answer report. And so in the SAM project, it will sometimes ask you for a answer report. If you clicked OK in a hurry to look at your results, you wouldn't be able to get back there unless you rerun Solver. If I highlight it and click OK, it will then generate, and on a new tab, there will be a tab called Answer Report 1, which documents what your solver model did. Where did it start? Where did it end? What were the outcomes of all these? And again, anything that has a slack value of zero, meaning it's a binding constraint, is something that is holding you back from making more net income in this case. And there's a theory, a management theory called the theory of constraints. So if you're managing a group of people, the theory goes you want to, understand what's holding them back. Is it, number of hours in a day, or do they not have enough, trained people, or what is it that is holding them back? And then you work on those, constraints to, then grow the business or grow their output. And in this case, the binding constraints are actual physical inventory. And so in a manufacturing sense, that's quite easy to measure and quantify. And so you get an answer report in that way. If I go back to the financial analysis and I go back to Solver, the nice thing about Solver is it remembers what you have done. If you wanted to save this particular set of constraints, it's not quite like a scenario manager because, in this case, we've got all of these different moving pieces, but it does have the ability to load and save. And so if I click save, load and save, it's the same button. it will ask me where do I want to save this. And so if I were to just say, well, let's put it down in cell A22, I click save. What it will do is it will put in some cryptic looking output. I don't necessarily know exactly what those things mean. I could look it up, obviously, but to Excel, it knows that these numbers, these true falses, etc., are related to certain settings in Solver. And so, if Sam asks you to save your Solver model, again, it's not like saving it with a name in a file or in a name in Scenario Manager. It's saving it in a range of cells that's pretty compact. And if you ever needed to load that, it would then again ask you, what's the range of cells that contain that set of data. And so that is a brief but quick overview of Solver. Again, we're not going to have to build Solver models, but we are going to have to know how to install Solver. We're going to have to know how to apply Solver to an existing spreadsheet, translate the goals, the constraints, whether we want to maximize or minimize into a problem that already exists. And so I'll leave it there. If you have questions, feel free to reach out. Again, the homework you're working on in preparation for next week's exam is the Module 8 SAM project. Have a good day, and we will talk to you soon.